Hello, in this video, let's try to understand how machines really learn from a slightly mathematical perspective. We are not still going very deep into maths, but we'll do it gradually. So let's understand how machines really learn. Now again, we have taken the same example, the price of the house and area of the house. Right? So these points represent the area of the house and these points represent the price of the house. And we have 5 training points. In the sense, we have 5 set of points where we know their areas and where we know what is the price. For example, this is about 1000, I don't know, 1000, slightly more than 1100, this point, and its price is nearly 44, you know, as in Indian rupee, 44 lakhs, right? Now the question is that if we are thinking in terms of a model, right? Again, I've still not defined model, but for now let's consider that we want to represent all these points via some curve, right? In the sense, or even a more simplified question would be, if I have to pick a line, right, which best represent these points, what would that line be, right? And so line actually is the model, right? Why do I say that line could be a model? Because model is something which learns from the data, and this line, let's say one of the lines right now, is a model because it kind of represents the data, right? It does not represent all the data because not all the points lie on this data, but it is a representative of these points. And more importantly, once we have this line, mathematically we can get its equation, and once we have the equation, we actually then have the ability to predict the future prices in this example. So to clarify, what I'm saying is that once, let's say, we have picked up a line, right? Let's say this red line as the one which represents a model, then all we need to do is, let's say we actually want to predict the price of the house and we know area of the house. All we need to do is actually give the area of the house in this line and get its price, right? So we know from our school mathematics that, you know, equation of line is y equal to mx plus c, and here y is the price of the house and x is the, you know, area of the house. Once we have figured out the equation of the line, when we want to find a future, we want to find a price of a house where we know the area, all we have to do is plug into this equation, put the value of x, which is the area of house, and get the price, right? So broadly, you can think that for this example, that machine learning is curve fitting, or finding out the right curve, right plane, right set of surface which kind of captures all your points. Now, you know, so far so good. The question is that here I have 2 set of lines. Now how do we decide which line actually represents best all these points, right? There could be I have just put 2 lines, there could be multiple lines. Now this is where, you know, the algorithms start coming into picture, and here we shall talk of a concept called a cost function, right? Now, even before getting to what is cost function, if I have to decide between these 2 lines, I need some rule, right? So I would say one rule could be that we find out the difference between what the model says about a price and the actual price. So what I mean is that, let's say this is the line, right? These are the actual points which I know, right? Which I have, these are my training examples. And this line, right, is a difference between what the model thinks and what the actual price is. So actual price, for example, is this. So it's about, you know, something less than 50. Whereas, the model thinks the price is around less than 50 for this point. Whereas the actual price is something more than 50. So there is a difference. Let's say the difference is about 2, right? So if I take all these differences and add them up, right? Then the line where the differences are the minimum could be said as the best representative of the model. Why? Because when I sum all these distances, it's the difference between what the actual prices are and what the model is predicting. If that is minimum, we could very well say that this line, is the best suited to represent these points. So I've simplified this whole argument, but this is the gist of it, that you have something called a cost function, right? Which a machine learning algorithm takes when it is actually learning from the data. What it is doing is it is actually predicting the difference between what it thinks based on its own model and the actual. And when it has a lot of multiple options, then it picks up the model where the difference is minimum, right? Somebody would ask, why does there need to be any difference? Why don't we get a line? Why don't we get a curve which fits all the line? So we'll see some other concept like overfitting, because when we are actually building a model, we are using the training data. Now, training data does not mean the real life data. So you want a model which kind of really represents the real world. You don't want the model to just really fit the training data and then fail on the real life data. What I mean is you could very well create one equation of a line, equation of a curve which passes all these points, but that would in machine learning terminology be overfitting, because it has learned so much from the training data that its ability to predict is very, very wrong, right? We'll see these concepts in detail, but for now what I want to impress upon you is that a model, if it is thought as a line, there could be multiple lines, and to decide which line is the best, a cost function is used. A cost function is simply a difference between the actual value and the value which a model thinks based on its own algorithm, and the minimum of these differences, right, is the line which the algorithm selects. So this is at a very high level, and we will see these concepts again as we keep doing other videos.